The use of the term ECU may be used to refer to an engine control unit. However, ECU also refers to an electronic control unit, which is a component of any automotive mechatronic system, not just for it to control of an engine. In the automotive industry, the term ECU often refers to an engine control unit, ECU, or an engine control module, ACM. If this unit controls both an engine and the transmission, it is often described as Powertrain Control Module, PCM. In this lecture, we will discuss the ECU as an engine control unit. Fundamentally, the engine ECU controls the injection of the fuel and, in petrol engines, the timing of the spark to ignite it. It determines the position of the engine internals using a crankshaft position sensor, so that the injectors and ignition systems are activated at precisely the correct time. While this sounds like something can be done mechanically as was in the past, there is a bit more to it than that. An internal combustion engine is essentially a big air pump that powers itself using fuel. As the air is sucked in, enough fuel has to be provided to create power to sustain the engine's operation while having a useful amount left over to propel the car when required. This combination of air and fuel is called a mixture. Too much mixture and the engine will be full throttle. Too little and the engine will not able to power itself or the car. Not only is the amount of mixture important, but the ratio that mixture has to be correct. Too much fuel, too little oxygen, and the combustion is dirty and wasteful. Too little fuel, too much oxygen makes the combustion slow and weak. Engines used to have this mixture quantity and ratio controlled by an entirely mechanical metering device called a carburetor, which was a little more than a collection of fixed diameter holes, through which the engine sucked the fuel. With the demands of the modern vehicles focusing on fuel efficiency at lower emissions, the mixture must be more tightly controlled. The only way to meet these strict requirements is that handover control of the engine to an ECU, the engine control unit. The engine control unit has the job of controlling the fuel injection, ignition, and accelerators of the engine using the digitally stored equations and numbering tables rather than by analog means. Precise fuel management. An electronic control unit has to deal with many variables when deciding the correct mixture ratio. These are engine demand, engine temperature, air temperature, fuel temperature, fuel quality, varying filter restriction, air pressure, and engine pumping efficiency. These require a number of sensors to measure such variables and apply them to logic in the programming of the engine control unit to determine how to correctly compensate for them. An increase in engine demands, such as accelerating, will require an increase in the overall quantity of mixture. Because of the combustion characteristics of the fuel in use, it also requires a change in the ratio of this mixture. When you press the accelerator pedal, your throttle flap will open to allow more air into the engine. The increase in airflow to the engine is measured by the mass airflow sensor, so that the engine control unit can change the amount of fuel that injected, keeping the mixture ratio within the limits. It doesn't stop there. For best power levels and safe combustion, the engine control unit must change the ratio of the mixture and inject more fuel under full throttle than it would during cruising. This is called a rich mixture. Conversely, a fueling strategy or a fault that results in less than a normal quantity of fuel being injected will result in lean mixture. In addition to calculating the fueling based on a driver demand, temperature has a considerable part of the play in the equations used. Since petrol is injected as a liquid, evaporation has to occur before it will combust. In a hot engine, this is easy to manage, but in a cold engine, the liquid is less likely to vaporize and more fuel must be injected to keep the mixture ratio within the correct range from combustion. The temperature of the air also plays a role in combustion quality in much the same way as the varying atmospheric pressure.